So hope guys, good morning and may introduction lang tayo sa mixture problems natin. So in the next few days, magkaroon tayo ng mga problems na tungkol to sa mixture problems. But this time, parang ano lang muna, titingnan mo muna how the mixture works in a very visual parang paano mo siya tingnan the visual way or parang mas madali mo siyang maintindihan yung mixture para magbi-visualize ka every time na magagawa tayo ng or magso-solve tayo ng mga um, mixture related problems. Okay ba? Hello guys. So go.
Hi, I'm Marla Warburton. I teach Algebra 1, and this is how I teach mixture problems. And now, mixture problems. Mixture problems are perhaps the most dreaded type of problem in Algebra 1. People are afraid of these problems. Now let me read one to you, and then you'll understand why people are scared. A chemist wants to mix some 70% saline solution with 8 liters of a 25% saline solution to create a solution that is 40% salt. How many liters of the 70% solution does she need? Over the past 5 years, I've tried several different ways to teach mixture problems, and I just settled on this mixture picture, this common sense, and this seesaw method. To introduce the big idea, I've brought in some water and blue food coloring. This solution has a lot of drops of blue food coloring with water. I'm going to call this my strong solution. This solution has a tiny bit of blue food coloring, and I'm going to call this my weak solution. So I have a strong solution and I have a weak solution. I want you to silently think to yourself about what will happen if I mix, get it, mixture problem? If I mix a strong solution with a weak solution. And team talk. It's important to have that basic understanding that the concentration is going to be in between. And I don't think that that's obvious to everyone. So that's what I was going for first. Now I'm ready to mix. It's somewhere in between. So this is our starting point. Students take the information from the problem and put it into the mixture picture. Which saline solution is the weak saline solution? 25%. The 25% saline solution. In this case, 25 is the weak percent. And which saline solution is the strong one? 70%. 70 is the strong percent. And which is the in-between? 40%. Yes? Easy enough? 8 liters is the amount of the weak solution, so I put that under the 25%. And the question is asking us? Sure, X liters. At this point, I show students that they can solve this problem by common sense alone. How far is the weak solution from what we want? 50%. And how far is the strong solution from what we want? 30%. What does this make you think? So the mixture picture is a graphic organizer. It's a way for students to organize the information to solve problems. So how many liters of the strong do we need? 1. Less than 8 liters should be twice as much as this. 4 liters. But the numbers aren't always that friendly, and a formula can be very handy. Here is the equation that you've been waiting for. seesaw method. So I bring in the concept of a seesaw. Did you know that a big person can balance with a very small person, like an adult and a child can balance on a seesaw? How? How is that possible? Shout it out.
It depends on how close the bigger person is to the center.
Yes, it depends on how close
If he jumps down to
they are to the
Center.
fulcrum. Okay. And I show students that on a seesaw, weight times distance equals weight times distance, and try to make a connection between the seesaw and the mixture problem. I did see more students comfortable with actually solving with the seesaw method.
Because you have less of the strong and more of the weak. And
Yes.
And the farther the weak is, the closer the strong has to be to the fulcrum.
Bingo, say it again.
There you go. The farther the weak is, the closer the strong has to be to the fulcrum.
Exactly.
When she did the seesaw, that made it all make sense. It feels great. Something new I learned.
It turns out that weight times the distance to the fulcrum has to equal, that's the equation, this person's weight times this distance.
When she wrote down the equation of weight times distance equals weight times distance, that really clicked for me.
So weight is 8 liters, 8 times the distance, which is 15, has to equal the other weight, call it x, times the distance, which is 30. It doesn't get easier than that. 8 times 15 equals x times 30. Solve for x, and it turns out, as we knew, we need 4 liters of the strong solution.
So ano, excited guys? Excited now? Do you have now the idea of how the mixture or mixing of some 2 or 3 different solutions or 1 or more solutions mixing together? You will now have the idea of what is then happening in the mixture. So watch out guys, because in the next days magkaroon tayo ng mga problems na i-apply natin yung principles. Kaya as I've said, now that you know, hope that you already the great deepening ideas na matutunan nila tungkol sa mixture problems. Okay guys, God bless and till then. Okay, bye-bye.